All right, as people are still coming in, we'll go ahead and get started because it's a few minutes after the start time. I'm Brandon Chavis. I work for Amazon Web Services. I'm joined by Josh Rosso of CoreOS and Kraig, I don't know how to say your last name, of Ticketmaster, Amador. And today we're going to be talking about using the ALB, or Amazon Application Load Balancer, with Kubernetes. So the gist of this talk is that CoreOS and Ticketmaster have collaborated on a Ingress controller that allows you to spin up all the necessary resources to use the application load balancer with Kubernetes. So if you're not really familiar with all these concepts, we're going to kind of look at some of the things that are necessary to understand kind of how this works. After I explain some of the AWS concepts, Kraig's going to kind of dive into how the Ingress controller itself works, kind of at the code level. And then most of this talk will be a pretty sweet demo from Josh. So I'm going to make an assumption that if you're running Kubernetes, you're probably running some services that need to be exposed to the internet. And so there's definitely kind of a few ways you can already do this in Kubernetes before the adoption of the Ingress controller. So there's a few ways that you can do this, right? So the first way is a cluster IP. So you can expose your service by using a cluster IP, which is a virtual IP that's only accessible internally to the rest of your cluster, right? So if you only need your services to be able to consume this particular service internally, then you could use a cluster IP. Similarly, you could use a node port, which is also a virtual IP, but it's accessible from outside of the cluster. So again, it's a virtual IP that Kubernetes manages on your behalf. And then finally, if you're using a cloud provider plugin, if you create a service of type load balancer, Kubernetes will go ahead and provision an elastic load balancer, for example, on your behalf and configure the listeners on the load balancer to plug into your services. So it kind of takes care of all that for you. There is now a new way to do this, which is an Ingress. It's a new resource type. And this is not necessary to dive into all this quite yet. We'll talk about that in just a little bit. But Ingress at the top level is basically a collection of rules that determine how traffic should be routed to your service. So you can do things like give services externally reachable URLs. You can define paths and destinations for your traffic, how it's load balanced. You can terminate SSL. You can do things like name-based virtual hosting. So you have a lot more control over how things are routed to your services in your Kubernetes cluster. So in order to support an Ingress, you need two things. First, you create the Ingress resource, which is created like any other resource in Kubernetes. It's a manifest file that determines what should be created and how it should be configured. And then the important part is you need an Ingress controller, which is essentially an application that monitors the Kubernetes master for the creation of Ingress resources and says, all right, on your behalf, I'm going to go create all the things that are necessary to satisfy this Ingress request. So in this case, this Ingress controller creates the application load balancer, all these supporting constructs in AWS for the load balancer to work. And then also at this time, it creates Route 53 records on your behalf. So it updates DNS to your public-facing DNS to give you access to that load balancer. So the application load balancer, I want to talk a little bit about what that is and why you might want to use it. Because again, in the past, you can use an elastic load balancer, which is kind of we call it the classic load balancer in AWS now. But the ALB is now focused on providing layer 7 functionality, where the classic ELB is basically like a layer 4 load balancer. So this is built with microservices in mind. So in the classic load balancer here, basically primarily layer 4. You could terminate SSL, you could have TCP connections, you could have HTTP listeners, but you didn't have a lot of control over how your requests were routed on the back end, right? Basically, it was a least outstanding requests algorithm, so we tried to route requests to the least busy node in your cluster. Now, with the ALB, you have the ability to configure different routes or hosts. So you can use mydomain/API or api.mydomain.com and configure which target groups on the back end or groups of EC2 instances that particular request goes to. This is a little bit more efficient now than just passing a request straightforward back to Kubernetes and having kubeproxy kind of figure out which node that service belongs to. Now there's kind of a direct mapping. So for a feature comparison here, some of the notable stuff that comes with the application load balancer. Path and host-based routing, I think this is one of the most important components. We say container support because of the way target groups work. Now you can have an instance IP and port combo, which we'll talk about in just a little bit, which allows you to register basically multiple containers on the same host. And then this is kind of a big request for ELB, WebSocket and HTTP2 support. So these are both available natively in ALB right now. So there's a few concepts you need to know to understand how ALB works. So first is the load balancer object itself. You get a CNAME that points to your load balancer. You get an ARN, all the typical Amazon resource identifiers, which is pretty self-explanatory. On the front end, though, you create listeners, which are similar to listeners with an elastic load balancer. And these basically define on which port the ALB should be listening for traffic, right? So we support HTTP, HTTPS, HTTP2 on any public-facing port, essentially. The next important concept here are target groups. And so target groups are basically a collection of targets, as you might imagine, behind the load balancer, and they exist independently from the load balancer. So you can associate or deassociate them with different load balancers as you need to. They can also be associated with an autoscaling group. And they're regional constructs, which means they span availability zones, so you can definitely have that high availability built right in with your target groups. So each target group, as mentioned, is its own grouping of EC2 instances, and they all share a common health check. So typically target groups are used to associate different applications, perhaps, or different services behind your load balancer. And so with each EC2 instance, you can register it with a target group multiple times. So that means you can have multiple instances of your service running on each instance, and then it can register with different ports. So it can support like multiple instances of an Nginx container, for example, running in a particular target group. And then finally, rules. Rules are kind of the link here between a target group and the containers on the back end. So these are a set of like rules and conditions. So it might say like if a request comes in and the URL is api.myservice.com, we send it to this target group on the back end. So when the request meets the condition of the rule, a specific action is taken, and this is all configurable. So looking at rules, they can be either host or path patterns. But they can also be specific patterns that you configure, kind of like if you've used CloudFront in the past. We can look for any character sets and match them and then route them appropriately. So the full architecture here is essentially load balancer in the front. It has two listeners that are probably configured to listen on different ports. You might have HTTP on port 80 and port 443. And then we have a number of different target groups in the back end. So these might represent 3 different services behind your load balancer. We can have 3 different rules here that route to these different services all behind the same load balancer. So we might have a default rule where we just by default pass all the traffic to target group number 1 here. But any path, any request that comes in and has image in the URL somewhere, we forward it to target group number 2. And then finally, for everything that comes in with the host header app1.mydomain.com, we forward to target group number 3. And so this really lets you use a single load balancer for a number of different services in front of Kubernetes instead of a dedicated ELB for every service you want to run in your cluster. And so that's it for me. I'm going to pass it off to Kraig to talk a little bit more about the Ingress controller itself.
So, if you look at it, there's a pretty good synergy between what the ALB provides and what the Ingress resource is inside of Kubernetes. So it made a lot of sense for us to leverage Amazon's load balancer at Ticketmaster rather than trying to implement something with like there's already existing Nginx controllers for Ingress that build the same primitives but require you to set up an ELB in front of it and drive traffic to those. So really like what we were trying to do was remove all of the, like basically make it as easy and as like reduce all the complexity between like our applications running inside of Kubernetes and their like basically if we're trying to debug them or understand how traffic is getting to them, it's Kubernetes is new to us, and so diagnosing issues and understanding how things are happening inside is new for the company. So it's a whole new way for us to operate, especially inside of Amazon. We're used to having a completely different set of tools in our data centers. So, like this gets us to where we create the ALB, which we can just kind of trust that Amazon's done it correctly, and then worry about driving that directly to our pods. So, it gets rid of any kind of hops where we don't have to worry about like a newly managed Nginx pod that may be doing something we don't expect, or we're trying to figure out how that works. So really, it just makes it a lot easier for us to figure out how to manage it and everything else. So there is some existing, at least if you search around, you'll find some existing ALB Ingress controllers for Kubernetes, but those focus on having a single ALB for your cluster. We are trying to have as few of clusters as possible. We've got hundreds of products, and we don't want to have hundreds of clusters. So what we did when we wrote ours is we provisioned a single ALB per Ingress resource that's defined in the cluster. That way we don't have the same dependencies. Like we don't share an ALB for different products. If that one has like gets under a denial of service attack or just gets a whole bunch of traffic, it doesn't affect unrelated services. And so, we started off basically trying to leverage the Kubernetes API and libraries directly, and There's actually a really good Ingress, Nginx Ingress resource with like an entire library and everything you could build around it. So we used that, and it made it really easy, like a matter of like 3 or 4 days, I think, from having the idea to do and to having a proof of concept using that library, where we take the Ingress resource that's defined in the cluster, map it to what that would look like as an ALB, and then just reconcile the differences, right? So if you create an Ingress resource inside of Kubernetes with the different targets and different paths and everything, we just take that, we map it to what that looks like inside of Amazon, and then do basically the Amazon API calls to make that a reality. The hard part really was just kind of synchronizing with what we thought Amazon should have, and making it that way, and dealing with the different orders that kind of stuff can happen. But as far as integrating with the Kubernetes cluster itself was really easy, and it's super powerful. So what we have to do is take that Ingress library that exists now, implement the controller interface, which has, I don't know, maybe like 10 different functions in it. We really only needed 2. We needed one that's on update, which happens every time someone creates or changes an Ingress resource inside of the cluster. So we take that, and then we evaluate the ingresses that are in there with our current state of, or at least our view of what the state is supposed to be. And then after that runs, we run it will call the reload function on that controller, and then we reconcile those differences. So we go and we look at it and be like, okay, maybe a port's changed or somebody's added an SSL configuration, whatever those things are, and then we make those changes inside of Amazon. So that looks like this. This is a on-update function that gets called pretty frequently. And all we do is, right now the library is created with the idea of managing an Nginx configuration, which is a single Nginx deployment across all of your nodes. Ours is a little bit differently because we're creating individual ALBs per resource. So even though we're getting that Ingress configuration parameter, we don't actually use it. We go and use this store lister and iterate over all the ingresses inside of the clusters. A lister is basically like a caching layer to the Kubernetes API, so that you can go and hit this stuff a whole bunch of times and not overwhelm the API servers. And then we at the last line down there, you can see where we create the ALB ingress from that Kubernetes ingress object. And that's just, I would have put it up on here, but that's really like a huge chunk of code. It would have taken like 3 or 4 slides. But that's where all of the mapping happens. But you could always look at the code. And then the reload function, which is pretty simple, we just iterate over all of our defined ingresses and reconcile the differences. That we'll dig inside. There's like going to be, right now there's multiple load balancers, because when we wrote this, you couldn't do host-based routing with an ALB. Now you can. We're going to change that. But it'll iterate over the different load balancers for the different hosts inside of that Ingress resource, iterate over the target groups, iterate over everything else. And like if the cluster changes, like if you add new workers, remove workers, those targets will change. We can take care of that at that time too. So this is what it looks like, right? Here's your Kubernetes cluster. And then you fire up the ALB Ingress controller. It registers with the API server and watches for the Ingress resources to change. And then it'll push back any changes that may happen. So this is creating a new deployment. You'll fire up, some service A with node port A everywhere, another one B. So right now we expose, Kubernetes exposes the node port on every worker, even if that worker doesn't run the pod. So I'll come back to that. But right now, so what the Ingress controller will do now when you create a Ingress resource is it goes and fires up an ALB. And then it will create target groups for whatever services you define inside of that Ingress resource. So right here you can see that like service B, or service A on the left, it's got a black line going to node port A on the first worker. That's fine, but you've got the red line going down to the worker all the way on the right, because that one doesn't have a pod. There's an only local annotation you can put on your service, and it'll make the health checks fail from those workers. So this way, when we send traffic in through the ALB, it'll only go to a worker where there's a pod. It doesn't like do a horizontal bounce between workers. It's one way to make it easier to understand where your traffic is coming from. It also preserves the source IP. And then it'll set up listeners. So this is like, listening on port 80 or 443, that kind of thing with your certificates. And then it sets up the rules to route the request to whichever target group you define. This is basically what Brandon was just showing, except we have different ways of visualizing how this works, I guess. But it's essentially the same map or the same diagram at this point, just things moved around a little bit. But ultimately, at this point, you're nearly done. The one thing that we still do is recreate the Route 53 record that points to your ALB. We have talked about removing this because there is an external DNS controller for Kubernetes now that you can use to do this, and then we can remove this dependency. But when we started, the host-based or the host routing wasn't in there, so this was one way for us to be able to still implement that. Like if you created this with 2 different host names and you wanted to route to different target groups, we would just set up 2 different Route 53 records with 2 different load balancers that would have those separate configurations. And that's it. So Josh will give you a demo of how this stuff works.
Sweet. Hey, everyone. I'm Josh. I am going to mirror my displays real quick, so bear with me here. And basically, we're going to go through what Brandon and Kraig just described with a running ALB Ingress controller inside of the cluster. So let us give this a shot. OK. So inside of EC2 right now, I am running a couple different load balancers. Just want to make sure that nobody thinks I'm playing any tricks on them during this demo, right? So these are basically ELBs that are servicing a Tectonic-based Kubernetes cluster. Okay, these are the only load balancers that I've currently got running inside of here. Now, to prepare for this demo, I have also set up a couple different resources. Because like Kraig was saying, and Brandon was alluding to as well, one of the big things with this ALB Ingress controller is with layer 7 capabilities, we could essentially use an ALB Ingress controller to satisfy multiple services, potentially saving us a lot of money, and also just giving us a greater amount of flexibility than maybe a standard ELB would with the Kubernetes integration. So you can see up here, I'm running, well, in this case, I guess 3 apps, but the important ones to you is I'm running one called Echo Server, and I'm running one called MyNginx, okay? Now, in this hypothetical situation, I don't just want to tell Kubernetes, hey, spin up a load balancer for Echo Server and spin up a load balancer for MyNginx. I want a single ALB to actually satisfy these things based on a path or someday potentially a host that gets specified in the URL, okay? So also down here, I've got a bunch of logs that I'm going to kind of show you as I go through and create these things. Don't worry about the existing ones. And red doesn't mean error in this case, so don't get too scared. OK, so if we go over, right now, I'm just, again, showing you that there's nothing really set up. There's a domain name I'm eventually going to work with called echo.josh-test-dns.com, and it is currently not being satisfied by dig. OK, so there's currently not a record up there. All right, so let's check this out real quick. So first things first, I have an Echo Service Ingress YAML that I will show you here, and this is, again, very similar to what Brandon and Kraig were showing you. Along with a lot of the main features, such as the ability to say, hey, I want echo.josh.dns.com, whatever, to satisfy these 2 services. So you can see here, if I set myself up on the root path, I should go right into my Echo server. If I call out the MyNginx path, I should end up on my Nginx pod, right? So I've got those types of ingress functionalities, but also baked into this, if you go through the docs and read kind of the nitty-gritty, there were actually a lot of other features we really wanted to have some extended flexibility. And we've also put some of these upstream as well for ELBs. One of those was tagging. So a lot of you who run in Amazon know that tagging is super important, and you need to make sure that things are tagged based on the team using it and so on. So we've got annotations added in here that ensure when it's created, these appropriate tags are added. We've got more flexibility around explicitly calling out what subnets you're going to drop this ALB into if you want. So those of you who have used the ELB know you can kind of do this with like tags in AWS, but primarily nice for us to explicitly call this out when we need to, because we need to land ALBs all over the place in different subnets and so on. And then a bunch of other features that we can just call out with these annotations. But when all is said and done, I want to satisfy this ingress resource by creating this DNS name and being able to route into these 2 unique services. Sound good? All right, so let's do it. So I'll come inside of here, and this little box in the top right corner, you're not supposed to be able to read it, so don't worry about that. I'm just going to run my kubectl apply command from there. Echo server ingress. OK. All right, and we'll make sure the logs are still going as well here. There we go. OK, come on, red logs. Perfect. All right, here we go. So I run this. I am also querying up in the top here the service. So you can see the Ingress service up here has now been registered inside of Kubernetes. And you'll notice I'm obviously starting off with as Brandon alluded to, that main ALB object. So I've generated an ALB inside of Amazon's architecture or infrastructure. I have started the Route 53 record set creation. So we're doing a couple things here. One is we're creating a DNS record, but we're also going through and asking Amazon if that DNS record has propagated fully. So we don't continue on until we get verification that this guy has propagated. And once this does go through, usually this takes the longest, maybe like just shy of a minute or so. Once this goes through, we should see a bunch of other stuff shoot up from the other work it's doing. So as you had heard, it's setting up things like target groups and listeners. I also, although I failed to mention it, let me go back into this file. I also am partially using HTTPS. Just to be obscure and weird, I'm doing it on port 80. So HTTPS on port 80, where I'm also using a certificate that I've got inside of Amazon. And you can use a certificate from IAM, or you can use a certificate that you've got in Amazon's ACM, their certificate manager as well. So, okay, now there's a lot more junk down here, right? But essentially, all these things that we've been talking about have been created to satisfy this Ingress resource you've been looking at. Route 53 is created, the target groups are created, the listeners are created, and the rules are created. And I'll show you what all of these translate to here now. So while we're looking inside of the Amazon console, let's just do one thing for fun. We're just going to do a quick watch dig. The SOA record over there should eventually update with the A records for the 2 IP addresses representing the ALB. But we'll just keep that running in the background while things are going. So inside of Amazon, we now have, if we refresh, a ALB. And this ALB is set up with the name of my cluster, which I've called dev1, along with kind of like think of it like a hash type thing that represents what this ALB is satisfying. Some of the annotations I put in, like the subnets that I explicitly called out in this case, it ensures that this particular ALB is dropped in the exact subnets that I want it to be dropped in. And you'll notice it's also in a state of provisioning. Now, let's go down those layers. So remember that diagram in your head if you can, right? We've got the ALB object right now. If we go inside of listeners, as you saw with my annotations, I was exposing port 80 on HTTPS, again, just to give you kind of a weird use case. And I also was exposing port 9000 on HTTP. So we've got 2 listeners, 2 ports that this guy is opened up on and listening for traffic. You'll also notice that it is referencing the SSL certificate that I had specified in the Ingress resource as well. Taking that a step deeper, these listeners have rules attached to them. So if we go into the rules for this listener here, each listener, in this case 80, has the rule set up. So at the top here is the MyNginX, which points to a unique target group. So remember, those target groups, like Brandon was saying, can point to a group of machines. So when something comes up on MyNginX, all of the things in the target group 32369 are going to go in, which should represent the pods for my Nginx controller. And then as you can imagine, just the /, which we'd call the default, right, is going to get forwarded to the target group 31805, which represents the pod for my Echo server. Okay? So I'm satisfying multiple services all inside of Amazon with the provision with the technologies they have available. There's no extra Nginx layer, there's no extra proxy layer. This is all happening layer 7 inside of Amazon. Now, if we go back to our dig command, timing is actually working really well. We now have our IP addresses. So clearly, I won't bother going to Route 53, but clearly the DNS record has been created here, and it is now pointing to the ALB itself. Very good. So since that's pointing to the ALB itself, if I come into a web browser real quick, and inside of this web browser, I go to HTTPS, Josh test DNS, Josh-test, actually it was Josh, echo.josh-test-DNS, yeah, try to make it as confusing as possible, on port 80 and hit enter. It comes back, again, I'm using a self-signed cert, or a cert that my browser doesn't trust, let's say, inside of here, and now I'm getting the Echo service back on port 80, right? Which is great. And now if I come in here, again, I know the URL bar is tiny for a lot of you. If I come in and say MyNginX and hit enter, exactly what I would want. So again, the power here is I've got this single ALB that I can now go and add things to, remove things through, and it can satisfy really as many resources as I want, as long as there's enough rules left in the ALB for it to satisfy. So that routing is very, very simple. And then, of course, being a Ingress controller that we're trying to use for all of our services, not only is it able to bootstrap things and, like Kraig said, reconcile, but that reconciliation pattern is also good for modifications and changes. So when the day comes that you say, oh, you know, I really didn't mean to put this on port, I think I did 9,000 for HTTP, we'll see. Let's take that little S out of there real quick. Perfect, okay. When the day comes that you go, you know, 9,000 is not really the right port for me, I meant to do 8080 for HTTP. It would really suck if you had to reprovision all those resources again to change that, right? So this controller kind of introspects not only the deltas when it reconciles, but also what it needs to change in the Amazon stack, or I guess in the ALB in Amazon, to make that change happen. So hypothetically, if we were to come in here and say, hey, kubectl, let's edit the Ingress resource echo server, and hit enter. Now I'm directly modifying the manifest such that if I save, it should impact these changes. If we come in here and we say, that was a terrible idea, let's fire that person who put in 9,000, and then let's use 8080 instead, I'll hit enter, and this will save up. My Ingress resource, although I left the logs non-conveniently, should essentially tell me, hey, you know, I'm going through and I'm setting up some new rules in a new listener. You can see the start listener creation and start rule creation down here, right? So it's going through and doing the modifications, which then translates up to our service. So back inside of EC2, we'll back off real quick here. Let's look at the listeners now. And you can now see we're exposed on 8080. No teardown, no reprovisioning, just a delta change in this case. We come inside of our browser, and as all of you could have guessed, if I go to 8080 now, it is going to do the exact same thing. So it's going to resolve into that pod. So again, just keeping that reconciled state up to date through ALBs is really the power of what we're adding here with this ALB Ingress controller. And it's running in production at Ticketmaster. We use it for all of our clusters. And you know, our big thing was just really trying to put this out there and see if it could benefit the overall community. So I'll go in and just kind of remove it real quick from here. So if I go back to my apply command and just do a quick delete, in this case, it will go through and start the deletion process for all of those different resources. You'll see it also leaves Kubernetes from my top left of my screen up here where my Ingress resource was. And of course, if I come back and do a refresh, you can't really see it, but it's spinning indefinitely up there. It can no longer access it because the ALB is effectively gone during that last reconcile. So the last thing I'll say on this project, and then we'll probably have about 10-ish minutes or 9-ish minutes for questions for those of you who are interested in this. We currently have this in a CoreOS repo called ALB Ingress Controller. And we're not really sure where the home of it would eventually be. You know, maybe someday it'll be an incubator project or live somewhere else, but nonetheless, we're keeping it in the CoreOS repo for now. We've got docs going over a lot of the things that I've described inside of here. And again, just to kind of reiterate my half-finished thought, we did this for Ticketmaster because we saw a real need in doing all the layer 7 stuff in the ALB, especially considering how capable these ALBs are now in Amazon. But if it's something that is a potential big use case for yourself as a company, hop on our GitHub page, give us feedback, file issues. We've gotten pull requests from folks, issues from folks, and we're just trying to refine this more and more so that, you know, selfishly, so that Ticketmaster can benefit from your contributions, but also so that the work Ticketmaster has invested can go into the larger community and hopefully help some of you out someday as well. That's all I got, so thank you so much. Appreciate it. We have exactly 8 minutes. Is it cool to just go with some questions until 12 o'clock? If anybody has anything, feel free to raise your hand and shoot it at us. Yes, please.
The actual definition of the Ingress controller that you have there?
Yes. When you say definition of the Ingress controller, do you mean like?
In the YAML file.
Oh, the YAML file itself. Sure thing. Oh, well, it's not in the cluster anymore, so maybe I should look at it locally.
So, with you defining the certificate arm in the annotations,
Yes.
are you able to have separate certificates for different hosts down in the spec?
Not today. So we looked at it we actually had this exact conversation with Ticketmaster. We said, we don't have right now the need to kind of map that to different hosts, although the community has wanted it and has mentioned it. So hop in if you have a chance, and this is something that interests you. If you don't see a ticket in GitHub, file one so that we can track it and knock it out. But at some point, we just got to figure out what's the elegant way to say, like, okay, this guy should map to this cert. You know what I'm saying? So we're open to proposals on that. Absolutely. Yeah.
Oh, so going back to that, some of the guys at Zalando, which have also implemented an ALB controller, were talking about just basically using the hostname and then searching through the existing certificates to find one and apply it, so that you don't have to specify it, because it is kind of a headache to have to put the ARN in there.
Yeah.
So.
Yeah, I had a similar-ish question. Your subnets are essentially hard-coded IDs,
Right.
which I guess makes this non-portable. I mean, anybody else wanting to deploy something similar with a different set of subnets would have to go and update that stuff. Have you guys given any thought to kind of making it more portable? And maybe what's missing is Kubernetes having the concept of a subnet and some of the network constructs.
So you can use the name for the subnet, like if it's the name, and then also we basically at Ticketmaster use Helm for everything. So even though people will define those, if you're deploying it to different clusters in different subnets, those would be variables, and you can just do that. Yeah.
Yep, and for what it's worth, we will have a feature in as well too pretty soon here where basically we say, hey, if you don't give us a subnets annotation, we'll do exactly what the ELB integration does. We'll go through and say, where are those tag subnets, and boom, done deal. So.
How do you surface errors? And I mean, does the controller do retries and do exponential backoff when it can't do something it's supposed to do?
Do you want to take
Yeah,
it?
I
Go
mean,
for it.
so what people right now will do is look at the logs of that to see if something went wrong. But yeah, it'll retry on the next reload anyways. So even if it fails something, it'll continue to retry that. But we don't have any kind of within that single reload like an exponential backoff to retry those things.
Basically following the pod logs for the Ingress controller itself is kind of where you would monitor to see the actual AWS API calls. And there's actually an annotation you can put on this that makes sure that all the AWS API calls are logged to the event stream for that particular pod.
And we do like a lot of describing in AWS and kind of seeing what the resources are, and we have some caching mechanisms in there as well. So some protections against slamming the AWS API just because an Ingress resource was put in incorrectly, things like that. So
We slammed the API for a while. We
it was
caught
bad.
on to that.
It was real bad. Yeah.
So I don't know, in one of those examples of code, there's actually Prometheus metrics in there. So we've been trying to add measurements and those kinds of things. You could build dashboards or alerts based off of that stuff too, and really see how much you're hitting the API, or if it's failing.
Hey, the question is about policies on ELB. On traditional ELB, you have this stickiness and this kind of policy. Do you support this?
Not yet. I don't know if you could do stickiness with ALBs. Can you? I don't remember seeing it, but yeah, all of that kind of stuff. If that's something that people need, you can open up an issue and we can get to it. But all those kinds of stuff, like tweaking the health check intervals and stuff like that, is stuff that I want to implement. Especially because the first time you fire up an ALB, it can take a minute or two for the health checks to start passing. So we would do that through annotations just to kind of keep it out of the Ingress spec, but open an issue.
And also, it's the design. I think you touched it briefly. How do you actually organize your whole thing? Which one should share ELB, which one should not? Is just economic reason, or there are some other design principles?
For us, it's we really try to not share anything anywhere, just because there's so many teams and so many products and so many hundreds of services that it really would it creates contention where we don't need it. We haven't, at least some of the people that have raised issues with it so far are related to it will provision an ALB per Ingress, and if you're a small startup, that $100 here and $100 there will really add up over time. So we'll have to figure out other ways of doing that. Something else that's come up that maybe what Josh has pulled up is, if you want to have an ALB and route different paths to different services that may be running in different namespaces in different Ingress resources, how do we know which ones to join into one ALB Ingress and which ones shouldn't? So that's still very much a hot topic. We're not sure how we want to do that.
Yeah, in
Is that
theory,
what
the
this was?
limitation is
Exactly.
Yeah.
on an ALB, you can have up to 75 different rules. So you can have, in theory, up to 75 different services behind an ALB and have them routed differently according to those rules.
Yeah, and we're really trying to define the line of like, okay, we want this awesome flexibility the ALB gives us, but we also want a way to express it in an Ingress resource YAML that's not going to read like an encyclopedia, right? Expressing those relationships and so on. So we're actually implementing host-based routing right now, and we have a proposal up in the host-based routing issue, kind of describing some of our thoughts on how this should be approached and how those relationships should happen. So those of you who love reading RFCs and proposals and things like that, check it out. Add comments if it interests you. So.
Good.
Thank you so much. Appreciate
Thanks.
it.